Good evening, students. So, this is the fifth session of your class, chapter number 2, Introduction to Data Structure and Stack. The actual data structure and algorithm concept of your syllabus that is, starts with this the chapter. The concept is that introduction to data structure and stack. The first of all, what do you mean by the data structure? The data, which means that it's a raw material, either it is a number or it is a text, that is an alphabet, or it is the audios or videos. The anything we can call it as a raw material, that is a data. The structure is that it is the way of organizing, that we can call it as a structure. So that the data structure is the specialized format for organizing and storing the data in the computer system. This is the definition of a data structure. The data structure, it is the organization and storing the data in the computer system. That format we can call it as a data structure. On the other hand, the definition of data structure is the way of collecting and organizing the data in such a way that we can perform operations on these data in an effective way. This is the definition of an data structure. The data is a raw material. The structure is a format for the organizing and storing the data in the computer system. So this is we can call it as a data structure. So here is the classification of data structure. The data structure is mainly classified into the two types. One is the primitive data structure, another one is the non-primitive data structure. The first is the primitive data structure. These are all the built-in data structure such as int, float, char, double. These are all the some of the examples for the primitive data structure. The second category is the non-primitive data structure. The non-primitive data structure or data structure, which is classified into the two more types. One is a linear non-primitive data structure. Another one is a non-linear non-primitive data structure. The linear non-primitive data structure, the examples which are arrays, stacks, queues, and the linked list. And the non-linear non-primitive data structure, the examples which are the trees and graphs. First, let me know about what is the primitive data structure. The primitive data structure, these are all the data structure that are directly operated upon some machine level instructions. This is we can call it as the primitive data structure. Already I told that the some of the examples which are int, float, char and double. That is pointer also. So that for example, int, it is a data type which holds the memory of the 2 byte. So that this is one general example. Then the operations on the primitive data structure. There are the various operations that can be performed on the primitive data structures, which are create, select, update and also destroy. The first operation is an create. So we can creating a new data structure in the computer system. So that is the first operation. This operation is reserves the memory spaces for the programming elements. So for example, int n, which is equal to 15. Here the n is a variable. The data type is an int. The value is an 15. The 15 is the number which assigned to the variable n of the type of int. So the memory space to be created for the n of an 2 byte because it is an int data type. The second operation is an select. This operation is used programmers to access the data within the data structure. This operation updates or alters the data. Then third operation is an update. This operation is used to change the data of a data structure. For example, int n is equal to 5. So we modify the value of n to store the new value 5 in it. This is a general example. The last operation is an destroy. This operation is used to destroy or remove the data structure from the memory spaces. So, in the C programming, we can use the destroy data structure by using the function that is called delete. So, these are all the some of the operations which can be performed on the primitive data structure. The next is non-primitive data structure. What is the non-primitive data structure? The data structure that are derived from the primitive data structure, which are called, we can call it as a non-primitive data structure. The non-primitive data structure, these are all the data structure that does not depending upon some of the machine level instructions. So that is called as the non-primitive data structure. The non-primitive data structures are arrays, linked list, and files also. This non-primitive data structure can furthermore classified into two different types. One is the linear and also non-linear non-primitive data structure. The first is the linear data structure. So what is the linear data structure? Linear data structure are the kind of data structure that has the homogeneous elements. These data structure in which the elements are in the sequential manner, so that we can call it as the linear data structure. The some of the most commonly used the linear data structure which are stack, queues and also linked list. Then the second definition is non-linear data structure. These are all the data structure in which the data item is connected to several other data items. So this is the definition of a non-linear. In the non-linear data structure, it may exhibit either a hierarchical relationship so that the data elements are not arranged in the sequential manner. Some of the most commonly non-linear data structures are trees and also graphs. Then the operations on non-primitive data structure. There are the several operations which are performed on the non-primitive data structure. The first is that traversing. So it is a process of accessing the each element exactly once to perform some operation. That operation we can call it as a traversing. The second operation is, it is a process of adding the new element into the given collection of the data elements. So this operation we can call it as an insertion. So insertion we can know that we can adding the new element into the data structure. The third operation is an delete. It is a process of removing or deleting an existing data element from the given collection of data elements. This operation is called as a deletion. Then searching. The searching is the process of finding the location of the data element in the given collection of data elements. This is called as a searching. Searching is, on the other hand, the definition is that to finding the location of the element in the data structure, it is also called as a searching. Then sorting. The sorting is a process of the arrangement of the elements either in ascending order or in the descending order. This process is called as an sorting. The last is an merging. It's a process of combining the elements of two structures to form the single structure. We can call it as an merging. So these are all the some of the operations which are performed on the non-primitive data structure. Then let me know about the stack. The stack, it is the one example for the linear non-primitive data structure. So stack, it's an example for linear non-primitive data structure. So first of all, what is an stack? A stack is an ordered collection of an items where the addition of the new items and also the removal of an existing item which is always takes place at the same end. This end is commonly referred to as a top of the stack. The end opposite to the top which is called as a base. So once again I'll repeat. A stack is an ordered collection of an items where the addition of the new item and also the removal of an existing item which is always takes place at the same end. That end we can call it as a top of the stack. Here the most commonly So the most recently added item is the one that is in the position to be removed first. So that is stack, which is also called as an LIFO. That means last in, first out. This is called as a LIFO. So this is the general diagrammatic example for the stack. So here the item 1, item 2, item 3, item 4 and item 5, these are all the content of the stack. So that we can adding the new element into the stack, that process we can call it as a push. We can removing the element from the stack, that process we can call it as a pop. Here the last in first out, the stack, the ordering principle of the stack, we can call it as a last in first out. Here the top 5, this is a top of the stack position. So this is the one diagrammatic representation of a stack. So here the representation of stack in the memory. So how we can represent of stack in the memory? There are the two ways of representation of the stack in the memory. So that the one is that static representation using arrays. The second one is that the dynamic representation using the linked list. The first representation is the static representation of using arrays. The stack can be represented using the one-dimensional array. The items into the stack which are stored in the sequential order from the first location of the memory block. Here the pointer, that is at top, it contains the location of the top element of the stack. So here the another variable, that is MAXSTK. So it contains the maximum number of the elements that can be stored in the stack. So here we can using the two conditions. The first condition is that the top which is equal to MAXSTK. It indicates that the stack is full. So when this condition is used, so it is indicated as that is stack is the full. The another condition is that top equal to null. So which is indicated that the stack is empty. When first we can adding the new element into the stack, first we can check the condition top which is equal to MAXSTK. That means if the stack is full or not. So same as like that, we can deleting the element from this stack. So at that time we can use the condition top which is equal to null. So that because this first it checks whether the stack is empty or not. So these two conditions we can using the representation of the stack using the arrays concept. This is the diagrammatic representation. Here the memory locations which are the 0, 1, 2, these are all the index, and the stack grows in these directions, that is one first element, that is 1 is a number, that is a content which is added into the stack, then the another element 2 which is also added into this stack. So that when we can adding the element into the stack, the top is incremented by the 1 pointer. So this is the stack which is growing in this direction. So this is a one diagrammatic representation using arrays. The second representation is the linked list representation of a stack. So here the size of the array which needs to be fixed to store the items into the stack. If the stack is full, we can't insert the addition item into the array. So it gives the overflow exception. But in the linked list concept, we can increase the size at a runtime by creating the new node. So it is better to implement the stack data structure using the linked list concept. So this is the diagrammatic representation. The first node. First of all, what is a node? A node is it contains the two different parts. The first part which is called as an information field. The second part which is called as an link field. The information field, it contains the data. The link field, it contains the address of the next node. Here the 50. So this is the one node. The another node is a 25. It contains the node containing the data is 25. The another node which contains the data is 20. The start, it holds the address of the first node. So this is the one general diagrammatic representation the linked list representation the representation of an stack using the linked list. So this is the one diagrammatic representation. So in this concept, we can adding the one or more nodes to an stack. Thank you. This is the end of the session.